Good afternoon, everyone, and thank you for joining us today for the RRSM South East branch meeting. This is our penultimate event of the year, so it's nice to have you with us. Today, we're lucky to have Dr. Juan Kamla, Road Safety Manager of Gloucestershire County Council, and Joanne is going to be speaking to us connected vehicle data for enhancing road safety. If you have any questions during the presentation, if you want to pop them in the chat or the Q&A, and we'll take some time at the end of the presentation to answer these for you. Okay, over to you, Joanne.
Thank you very much, Julie. Good afternoon, everyone. Thank you for RSM South for inviting me, Julie and Lauren. Today I'll be talking about the role of connected vehicle data for enhancing road safety. I'll give you a bit of introduction about me and a general introduction about collision and data, and then we'll take you through data collection, a case study, which is my PhD research. What are the challenges and considerations when we are looking at the connected vehicle data? And then at the end, we will wrap up with a summary, and I can answer the questions as they come through after I finish my presentation. So I thought I will give you a bit of introduction about myself. Well, I am Juan Kamla. I am with BSc, MSc, and PhD biased civil engineer, I have to say, but each of these degrees different specialism. MSc was traffic and transportation engineering, PhD road safety engineering. I am originally from Kurdistan, which is located North Iraq, a town which is very beautiful called Shaklawa, and I did my degrees there. My early career also was there at the University of Salahuddin, and then pursuing a PhD brought me to the UK, and gradually I became British, and now my hometown since then is Nottingham, a really beautiful town. I've been working mainly in the field of academia, highways and transportation, research, private sector, and now just recently moved to public sector back in August to Gloucestershire County Council hybrid working. I'm still based in Nottingham, but I go 2 days a week to Gloucester, or sometimes more, depends on meetings and etc. But mainly worked in the field of road safety since I finished my PhD in 2016, and a lot of operational road safety auditor, very active road safety auditor, and also chartered engineer with CIHT, Chartered Institution of Higher Transportation. As a volunteer, I'm currently serving as chair of the East Midlands region, and I'm also a mentor and professional reviewer, and also I'm active researcher, independent researcher on my own time with Transportation Research Board in Washington. I will be going there this January, presenting a different topic, hopefully on the single vehicle collisions on high-speed routes and their impact of severity by age and gender. So that's my latest update research. So I will be talking you through the connected vehicle data, but initially the idea about the use of connected vehicle data, how I have started with it, was my supervisor's idea. When I came to Nottingham University, I initially wanted to do intelligent transportation system, but then the subject moved to this idea of using connected vehicle data, and when my supervisor told me it really going to be a good idea if you propose something around, do we really need to wait for a collision to occur for local authorities or highway agencies to put measures? So why we shouldn't be doing that, being proactive? And I say, well, that's a good idea. And that's how we started having some stakeholder engagement and around how the best we can achieve or receive this data, and how the best I can propose a methodology on the best use of this data. So I will be taking you through aims and objectives later on. But if you see the graph, like collisions have started really high, and gradually we've made a good really progress to a point which is now we are just stopped. It's just stopped at a range where we can't do much about it. And that's where we need to really think about out of the box and make the use of all the amount of data that's available, and one of which is the connected vehicle data. So that is, as you can see, so the connected vehicle data, I mean, in my case, will be hash breaking incident data. And as you can see, this is the stats of hash breaking incidents or report road casualties 10 years up to 2023. The sudden braking or hash breaking is always within the top 10 contributory factors to a collision. So that is the second reason we thought of using this data. And then another part of what I have just talked about, do we really need to wait for a collision to happen? And that's really aligned very well with the principles of safe system approach. So it's a very nice system. It looks at 5 pillars: safer road, safer vehicle, safer road user, safer speeds, post-crash response. But the most important is the management and that post-crash response, how we make use of these pillars, how we can apply them into practice. And the idea behind it came that previously humans being criticized that they were the reason for collisions, but then we have now come to the acceptance that human make error, that our body has limited physical ability, which prone to crashes really, and it depends on the gender as well as on the ages. And then they come up with the idea of, let's look at the road, let's look at the roadside, let's look at the people, the vehicle itself, how these vehicles are saved and how the items within the vehicle are built for all genders. So for example, lots of vehicles are being designed for male genders formerly, but now it's moving up across and then post-crash response, to what extent we deal with an incident when it occurs, how quick the fire services, hospitals, emergency, all of that being dealt with once a crash happens, because that could save many lives. So it is about, and on top of all of that, using the proactive data, which is connected vehicle data. So there are various types of connected vehicle data, but the one that I will be talking about is within this red circle. It's vehicle to device data. So the proactive approach or vehicle to device data, a lot of modern vehicles at and it is increasing on annual basis, luckily nowadays. So they have got canvas, they have got SIM cards, they have got sensors, they have got other types of black boxes, etc., where they can collect a lot of information. And a lot of industries worldwide, they use this information for various reasons, which I come across later on in the other slides. But mainly highway authorities can really now buy these products based on these data, and how the robustness about how these data affect collision rates. I'll talk about how important are these data. And then how these data is utilize it. So they have been, as I have mentioned earlier, so modern trucks have got some sophisticated data collection system. The fleet managers collect these data for various reasons, and the position of these vehicles for various reasons, either for logistical reasons, delivery timing, or for monitoring truck condition, or for monitoring driver behavior. So driver behavior is a really important factor to take into account. And that was the reason behind the data collection from the fleet manager. So for the case study, I have chosen my research. So I have to say that the first person who started investigating the use of connected vehicle data based on the proposal that my supervisor, Dr. Tony Perry, who's working at Atkins at the moment, gave me the idea. So it was back in 2011, nearly towards the end of mid 2012, I've come up with the proposal and the method, and we have engaged with Microlize Ltd at that time, and they have provided me with 2 years worth of data, and the data were massive across all UK's roads and intersections. And then initially we looked at the data and we have identified a lot of these clusters around intersections, and this is quite expected, and I will be going through more details here. So we have, before I go to aims and objectives, once we looked at it, I have found a lot of them around roundabouts. You say that's expected because they approach a junction and they brake hard, but these hash braking are considered, it's not just the braking, they pass a threshold, which I will talk about it later on. So they have considered hash braking, and they were happening within a certain distance, 350 meters of the roundabout. So I thought that I will be investigating that. And the main aim was predicting those the collisions. So it was the idea, can we use hash braking incidents, which came from connected vehicle data or live data, can we use it as surrogate for collisions? That was the first thing. Second one, so can we predict collisions based on this type of data? And if so, finding could be useful for identification of locations with high collision risk without waiting for a collision history to develop. So then I have started relating the number of heavy vehicles hash braking incidents to a range of explanatory variables, geometric and traffic, and also identifying the relationship between collisions and also hash braking incidents, and then explore if hash braking incidents can contribute to the prediction of collisions for all vehicle types. So they, as I've mentioned, that hash braking incident is not just a braking that vehicle have undertaken. It is a sudden excessive reduction in a truck speed or heavy vehicle speed caused by bad forward planning for the situation, close following, sudden change in traffic signal or junctions, etc. And that braking it's considered as hash braking when it approaches, when the G-force for heavy trucks approaches 8 kilometers per hour per second, or 16, which is equivalent to 2.2 to 4 and 4.4 meter per second square. So high G-forces. And if that deceleration extends over a specific period of time, then it is flagged within the heavy vehicle, and the GPS of the location is recorded, and then it's sent via a sensor to the office, and that data is collected, and that's how they forward me the CSV files of these hash braking incidents. They all being coded, all these data. So as I have mentioned, I've selected then 70 roundabouts on the M1, M6, M5, M42, and some of them on the I roads. And for all of these roundabouts, they constitute 284 approaches, and I've identified hash braking incidents and also collisions within 350 meter radius from the center of this roundabout. So we had about 100, and that's why it's good to use connected vehicle data, because you're gonna get a lot of incidents in a period of time compared to collisions, which could be a good use of identify location with high risk. So I had around 153 heavy vehicle hash braking incidents in a period of 2 years, and 61 collisions in the period of 11 years. So the 11 years being used so that we can compromise that we are using a data set that's equivalent to the data that we have chosen, which is hash braking incident, because I need it for modeling purposes, which I touch upon later on. And you may come across, just notice I'm using truck here a lot, but you all be aware that during my PhD, I used a lot of American words because I was referring to literature review from US. So and came from a different background who used American standards. So at that time, I was referring to American terminology. So truck, I mean by truck, it's heavy goods vehicles. And then the data that I have used, they were from 8,000 trucks monitored in the UK over the period of 2 years. 93% of them, they were heavy, 18 to 20 ton, and then over 190,000 hash breaking incidents. And I've mentioned they've been driving from either the CAN bus, but not all the clients of the microLICE company were installed with CAN bus. They have got other types of technology that collected this data. And then what I needed to do is because for a PhD research, you need to make this data validated. And the first thing that I needed to do is to identify internationally what is a rate or a deceleration, longitudinal deceleration rate considered as hash breaking incidents. So I've got a whole chapter in my PhD thesis, which you can find. It's available to public from Nottingham University available. And a whole chapter is dedicated to various literatures worldwide who has concluded that 1.96 meter per second square for a heavy vehicle considered hash breaking, and and it varies by the type of the vehicle and also how heavy is the vehicle to 8.44 meter per second square. In addition to literature, I also, with my supervisor and also with microLICE Ltd in October 2012, we visited Transport Research Laboratory. At that time, TRL having the simulation, not just the simulation, also practical tests field area. And we have undertaken lots of track test trials there, various speeds, various maneuvers, and we have identified that the mobile was used as an indicator within the heavy vehicle, and it was identified that a hash breaking between 8.5 to 8.6, it was varied between 8.5 and 8.6 meter per second square. And after the validation, I then started collecting data for these roundabouts. I have decided what I need to be doing. So my approach or proposal was something that never done before, and that was producing or creating a module that connects traffic and geometric variable to hash breaking incidents, relating hash breaking to traffic and geometric variables. And I needed to do the same model relating collisions to traffic and geometric variables on these roundabouts. So for that reason, in order to see my outcome of the modeling, to what extent I can use hash breaking as a surrogate variable. So I have received data, were collected all traffic data using public platform for average annual daily traffic. I used MATLAB because for AIDT is only available for main carriageway, so I needed to do some programming on the use of, on finding out the traffic on each approach of these roundabouts. I used area photographs, online mapping, and also did lots of tests in order to find out online mapping can be used or online measurement instead of me going to each of these roundabouts measuring the size. So I've done some practical on site and also compared with the online measurement, and statistically there were the two values, they were not significantly different from each other, and that's how I continue it. And then for collision data, we all know about the Stats 19 data, which is is a data collected by police, publicly available for on public roads. And I used, as I've mentioned, 11 years worth of data. And the goods vehicle were varied between 3.5 to 7.5 ton, and that's the stats at that time on the across the whole 70 roundabouts. An immediate comparison, I've identified that the majority of hash breaking incidents were at the approaches, while only 13% within the circulatory lanes, because some of the hash cornering were also on the circulatory lanes, but I haven't studied hash cornering. I just sticked with the hash breaking incidents. And that's compared to 67% of these collisions happened at approaches and 33 within the circulatory carriageway. And this is an example clustering of hash breaking incident collisions in a roundabout or on a roundabout within 300-meter distance. And then a lot of analysis has been undertaken, ANOVA test, GIS data processing, used gridding quiz, Google Earth, and also Excel to KML, summary stats, categorical and continuous variables. If you are interested to see the methodology, all of these really in detail being discussed in my PhD thesis. ANOVA analysis, really useful for PhD students who are working in the field of road safety. Variation inflation factor, collision investigation and trends, and detailed hash breaking investigation, and then a number of chapters for detailing modeling. So the statistical modeling and methods I will touch upon now. So the method that I used, it was called random parameter negative binomial distribution using LIMDIB software. I know it's a very complex method. That is at a time when I tried to find out what is the best module to use in order to correlate collision or correlate a hash breaking incident with the traffic and geometric variables. So initially, the researchers used linear regression, and then because linear regression gives you negative outcomes, and we know that collision or hash breaking, they are count data, and they can't be negative, and therefore researchers has recommended that you cannot use, and I highly telling that we cannot use linear regression at any stages when you correlate collision with any variable. So then researchers use it Poisson, but the issue with the Poisson modeling is that the Poisson possesses between the mean and variance. They say if a Poisson tells you that mean and variance are equal, but in reality, the mean and variance in collision data or hash breaking incident data is not equal. They are either higher or lower, and that's why researchers now moved on to the use of negative binomial distribution, which is still used in practice. However, what the outcome from negative binomial distribution tells you that a collision happens. For example, you get high collision when the entry width of a roundabout is wider. So the wider the entry width, the higher the collisions, and that is the certain answer. But that's what negative binomial distribution tells you. While then researchers really progressed, and Fred Mannering, who I was in touch with at the time, he's a professor in US, and he recommended that I should be using random parameter negative binomial distribution. This is it accounts for unobserved heterogeneity, which means that independent variable may change across the road intersection, including roundabouts. If I explain it in an easier term, what does that mean? That means that when an accident happens or a collision happens at the approach of the roundabout, because the approach was wide, it's not just because of how wide is the approach, it's because of other factors at the background that may not be considered, either visibility, either speeding, either weather condition, lighting condition. Random parameter will give you that uncertainty. It tells you that maybe 60% was because of the width of that approach, but the rest unknown. It's very useful, although it's difficult to apply it in practice, but at least you have an idea that there are other factors influencing the occurrence of the incident. So that's why I used random parameter negative binomial distribution, and it was a very novel approach on the use of this method at that time. So the models being developed for the entire roundabout, approaches alone, for within the circulatory alone, grade separated roundabouts, also for at grade roundabouts. And then what I've done also, so independent modeling for hash breaking incident, independent for collision, but I also did a model for only collision, but I used hash breaking as a factor impacting these incidents, these collisions, I mean. And so a lot of variables I've used it. I had limited access to various other factors due to the tools I was using at the time. So, but I was able to use entryway, signalization, circulatory roadway width, type of grade, and also number of lanes along with number of arm, percent of average annual daily traffic, and percent of heavy goods vehicle. So the modeling results, so I'm not going to go into details of these tables, but I've done at the same time that I tried to identify the factors impacting collisions, I was also assessing the model that I was using, random parameter negative binomial distribution, with the normal negative binomial distribution. And then you see between the two graphs that random parameter gives you a really good trend between actual value of collisions and predicted value of these collisions that I have identified. I have identified that the higher, which is expected, inscribed circulatory diameter, the more the collisions. But the factors that I have identified is that partially signalized roundabouts were found to be really unsafe compared to signalized and unsignalized, and also unsignalized roundabouts found to be unsafe for heavy vehicles. If you would like to go into details of these results, you can check chapter 5, chapter 6, or just go to the final conclusion chapter in my PhD thesis. But the aim here is to show how we can use hash breaking incidents. So I'm moving to so these are the modeling results that I've also identified for hash breaking incidents. And then this table showed that IADT equally for so I'm showing only for whole roundabouts. So the arrows shows decrease in collisions and hash breaking incidents due to increase in the variable. So the number of arrows also shows the strength of the relationship. So equally, IADT was impacting the three variables, all vehicle collisions, only collisions involving heavy goods vehicles, and collisions, and also the model for hash breaking incident modeling. Again, with the average annual daily heavy goods vehicle traffic, the same thing identified. For all of them, it was identified and signalized roundabout is safer compared to partially signalized roundabouts. And for some of them, it was find out that due to other factors, especially for hash breaking incidents, and also signalized roundabouts were found to be safer than partially signalized roundabouts for collisions involving heavy goods vehicle and hash breaking incident modeling. And similarly, other factors, there were a lot of similarities in the modeling results between especially heavy goods vehicle collisions and also hash breaking incident modeling. And so I also, it was really important. So the first conclusion was, yes, we can use hash breaking incidents as a surrogate variable based on the modeling results that I have identified. And the second thing, we wanted to identify if we have hash breaking incidents, to what extent they can impact the collisions. A lot of my modeling results, so I have related that along with traffic and geometric variables to the collisions at these roundabouts, the 70 roundabouts. I haven't been successful for the whole roundabout, neither for the circulatory. They were coming as always the traffic and geometric were stronger. However, for the approach, and this was possibly due to limited number of junctions I have modeled, but because I had 284 approaches, that gave me better results. And I have concluded that yes, hash breaking incidents can also impact in these collisions, which is also aligns with the Stats 19 conclusion around that always hash breaking is in the top even 5, not 10 of the factors impacting the collision on occurrences. So usually for every 100 hash breaking incidents, there is an increased number of 2 collisions. And that is good enough for us to identify a trend at a certain location, or to conclude that when we see a cluster of hash breaking incidents at certain location, we would expect that that cluster will turn into collisions in a couple of years' time. And that was the results that I have identified. And then what I've done actually back in February, I have revisited some of the locations that I have investigated back in 2011-12. And but before I go to that one, I see that there is different information in this slide. I just which is it is showing the reported number, percentage of, or report number of vehicles, or percentage of vehicles reported on collision with sudden braking assigned. That's the 6 years period up to 2023. It's still high, but it is safe to assume that many other collisions caused by other factors led to emergency hash breaking, for instance, speed or following too close. This implies that hash breaking incidents may indicate collision risk. So that is only purely, the stats here is only purely hash breaking, but we know that a close following and all of there are some other factors cause hash breaking, and they can be combined with the percentages shown here. So as I mentioned, I have revisited locations, some of the locations, not the whole 70, only the ones on the M1. And I wanted to identify how many of these incidents has been changed to collisions. And it was identified that there are 220 collisions within 500 meter. Of these, 458 vehicles involved, 7 persons involved in HGVs, and the majority of these collisions shunts. This is all indicators that shunt collisions, an indicator of a hash breaking. So, and then, for example, we've got this location, which is M1 junction 28. So that is the information I have in my PhD research about the data about this on this location, which has high number of collisions and also high number of hash breaking incidents. So the one with the red, it was 11 years collision. This is 2 years hash breaking incidences. So the collision within a kilometer of the junction, we had around 121 collision in 5 years, in around 6 years period of time, 2018 to 2023. High number of shunts showing that hash breaking may have caused these shunt collisions, and 42% of these collisions involved goods vehicles. So if I go back to the previous slide, this is hash breaking incident of heavy goods vehicle on the M1 junction 28 in 2011-2012. And then this stat is 42% of these collisions are involving heavy goods vehicles. That gives us an indication that hash breaking incidents are a variable that can be used to identify locations of high collision risks. In addition to that, nearly half of these collisions is shunts, another indicator that hash braking incidents are a factor to these shunts. And also, we should bear in mind there are other consequences of hash braking incident, which are indicators of reckless driving, which I have mentioned, close following, speeding, and also most part of a vehicle experiences stress. Frequent hash braking will result in frequent overheating of brakes, and that wears down brake pads and also potentially damages brake tubes, and that increases the rate of tire wear, reduces the lifespan of tires and their effectiveness, and various potentially hazardous situations. Now, I have been told by National Highways Regional Control Center, high percentage of the collisions or fatalities is due to tire, or a lot of breakdowns happening on our network is due to tire wear. So hash braking is not only important to identify location of high incident risk, it's also a factor that could be used to identify the how the tire is, it has an impact on tire wear. So, and because of hash braking, there are other parts going through pressure, valve, cylinder. I'm not an experienced mechanical engineer, my knowledge limited in that area, but the research showed that it will pressure these areas. And this will potentially risk of vehicle breakdown and also increases the risk of collisions. So, but also the data is not coming with challenges or considerations. The availability of this data, I am very pleased that this data is quite now available. Various companies worldwide are now having the platform. At the GCC, I've recently on behalf of my team, I've bought a platform that we can use it for various reasons. So the data gives you not just hash braking incident, it gives you speed surveys, it gives you origin destination, it gives you, it could be used for what's called evaluation purposes. So, but there are still, so in my PhD, I really had issues with finding out the driver behavior on why driver does a hash braking. So that is still, the information around that is quite limited. And also to what extent infrastructure support the real-time data, and policy and regulations, how we can imply the use of hash braking instance as a surrogate variable to identify location. And this is down to research and evidence, people like us, to force the government into the use of, or to change policies and use of this data, as it really helps to reduce KSIs, which we are kind of stuck at a point and we can't do much about it in the meantime, rather than just maintaining and not increasing that level. And so it should be useful to do further investigation, not just using the hash braking, other data. So useful to be done, and how they can impact collisions. So in summary, we know that collisions no longer decreasing, the need for additional road safety measure, use hash braking incident proven effective, influenced by traffic geometrics, similarly to total and track collisions, also found to be a significant predictor of collisions at roundabout approaches. As I said, for 100 hash braking, there is an increased risk of 2 collisions. And also hash braking can be used in conjunction with other factors, which will be valuable in studying collision risk, especially at approach of the roundabouts. And as I said, it's an indication of reckless driving, close following and speeding, and can impact on tire. And also highway authority should consider incorporating hash braking incidents into the road safety strategy. I think that's it, is where you can find, I'm happy for my slide to be shared with everyone, and you can find my thesis here, which I have referred to, and other publications could be available online. from my research gate account. And thanks a lot, everyone, for your attention. And I'm happy to take your questions, or if you have any thoughts, you can reach out to me. I'm available in LinkedIn, quite active there. So thank you also to Julie. Yeah.
Thank you, Jawan. It was a really interesting presentation. We don't have any questions at the moment, unless anybody would like to pop them in the Q&A now. But thanks for such a fascinating presentation. There's obviously a lot of hard work gone into that research.
It was nearly 4 years and 8 months worth of work, actually.
That's a lot of work.
Yeah.
Whilst we're seeing if people have any questions, is there any final thoughts that you want to leave us with this afternoon?
I would like everyone to make use or encourage wherever they work, to encourage make use of this data. If they are in the road safety domain, if they are traffic engineers, network managers, local highway area managers, I have police officers. In the meantime, when I procured the data recently from Campus, which we use at the Gloucestershire County Council, just recently awarded on the 25th of November. And now we are in the process of training individuals, and it has been found really positively, and we can see the benefits of it. And that's what I can tell, that make use of the connected vehicle data as much as you can, and don't be scared that the data may represent only 2% of the, let's say, or 3% or 5% of the vehicles around our network, because a lot of questions coming around that. And that's because these platforms have the data over a couple of years period. So for trends, you can use, instead of looking at, for example, ITC or tube data, it looks at a week worth of data, while in connected vehicle data, you use a year or a 2-year worth of data. So you have a trend here. And it gives you the speed profile of the location, while ATC gives you the speed at one point, but with the connected vehicle data, it gives you the speed profile across the whole network. And I highly recommend that we move towards more of use of connected vehicle data, as it really helps us to identify first location of high collision risk, to help police as well. They have found really useful the data for enforcement purposes and other purposes, and also for evaluation purposes. You apply, for example, you say that I'm going to reduce speed limit at that section of the road. You would like to see if the speed limit reduction without enforcement has had an impact. So you go after a year, look at the data, connected vehicle data, and identify if there is a trend in reduction. And if not, then you will think of adding measures and then revisit again to what extent these measures has had an impact on the reduction of speed limit. There are other factors we also add to our network, and it's good to also identify their effectiveness on various factors, either speed limit reduction, either journey timing, or what's called hash braking incident reduction, etc. So I can say, just encourage and motivate everyone to make use of connected, to not be scared of using this data, make use of it. And if we have any students or anyone would like to do a research, it will be good to we go beyond what I have identified back in 2016. So it will be good to go further down to other types of roads. I'm just giving now ideas for future PhD researchers. So maybe they can go and look for intersections. They can go and look for roadways. So there are a lot can be done with this data, and I highly encourage the use of it. Thank you, Julie.
Thank you for that, Joanne. It's great to see the benefit of your
Yeah.
research being put into practical terms and seeing the benefits from it.
Yeah.
We still don't have any questions, so it just leaves me
alright.
to thank you so much for giving up your valuable time to present to the Southeast Branch members today. Thank you for everyone that's attended, and we hope to see you at another RRSM event. Thank you and good afternoon, everyone.
Thank you.